Hello everyone, welcome to Pepcoding. So in this video we are going to discuss a question. The question is named as binary tree coloring game. So here we are actually playing a game with our opponent. So what is this game? The rules are defined here in this column, but I'll give you the brief introduction, like what is the actually game, what the actually game is, and how we are going to determine that if a player is winning or losing. So game is like this. uh, our opponent first will color, let's say he uses a red color, and he will color any random node that will be given to us, that which node he is going to color. So our opponent is going to color any random node in this binary tree. Now this binary tree going to have number of nodes as odd number of nodes. Here you can see total number of nodes are 11. So there will be a person who will be winner. So what is the game? First I'll tell you what is the game. So he will color the opponent will color any random node. Now we have to color, the second turn is ours, so we have to color, we can also color any random node. Now we have to determine, for let's say we colored this too. Now we have to determine that we have, in the end we have to determine that the number of nodes colored by the opponent and colored by us, which among those which is greatest, and the player who is going to have the maximum number of nodes colored is going to win. So in the end we have to return true or false, that is if we are going to win this game or not. So to win this game, obviously we have to color nodes more than this opponent's node. For example, we are going to get equal number of chances, but as the number of nodes is odd, therefore there will be a person that is going to color one more extra, that is one extra than the other player. For this, for example, at this place, let's say three colors this, we color two, then let's say three colors this 10. At the same point we color this 1, again three colors, let's say 7, we color this 4, three colors 6, we color 5, now three colors 11, and we make a color to this 8. Now 3 has the last chance, and 3 colors this 9. So here you can say that 3 has colored how many nodes? 1 2 3 4 5 6. And how many nodes are colored by us? The number of nodes colored by us, 1 2 3 4 5. So you can see here we are the loser here, right? Now this is an important thing, that we colored all the nodes. Now let's say I'll first write that x is going to be given to us. Let's say for here x is 3. X is the starting point, or the starting node where the opponent is going to color. Now to see if we are going to win or lose this game, what we can do, the approach is simple. That first we have seen that if we randomly color any node, that is not going to make us the winner, as we have seen in this example only, that we have randomly colored all these nodes and 3 colored these nodes, therefore 3 was the winner. So what we have to do, what we can do, I'll just go back and write this here. N is given is equals to 11, that is always going to be odd number of nodes. X is going to be, let's say, 3. Now what we can do, actually we have to look for a way to increase the result of blue to increase, and we have to look a way, or look a path, or look a certain method through which we can decrease the result of red. We have to look for a certain way through which we can decrease the result of red. So if this is clear, that we have to do both of these things, obviously. Now what we are going to do, let's say 3 has opponent has colored this 3. Now how we can actually decrease the result of red and increase the result of blue. Actually I forgot to tell you one thing. There was one more constant. This constant is really important, because this is how we are going to this is the main important point that we are going to use to win this game. Actually the thing was given that if you color any node, let's say if opponent has colored this node, then the possible nodes that opponent can color are its neighbors only. That means its connected nodes. For example, if if opponent colored this 3, he can only color either 1, 6 or 7 in the next step, right? This was the main thing. Now using this thing, how we can win? If we are able to think, if you are not able to think, I'll just share you that how we are actually going to do it. Actually, to increase our result and to decrease the red's result, what we can do is we can just color, that is, we can color 3 is neighbor only. For example, if I colored this 7, if 3 if opponent has colored 3, and if I color this 7, then the path, that is, one of these paths has been ended for 3. This means that now 3 can color to which nodes? 3 can only color to this 1 or this 6. 3 cannot come to this point, right? So with this, one path for 3 has been managed or has been blocked, therefore 3 cannot color there. Now using this thing, how I can win? I can do what? I can actually find the maximum count. What we can do actually, I have to just color, I'll just color its neighbor, but before coloring the neighbors, I have to keep one thing in mind, that coloring its neighbor will reduce one path for 3, but that path has to be the maximum path, so that if I color that path, I am going to get the maximum number of nodes, right? So what I am saying is, first what I'll do, I'll just count the number of nodes in left child of the 3, number of nodes in the right child of the 3. That is, we are going to maintain a left count and right count, and then we are going to find a number of count of the total tree excluding this 3 and its family. Okay, that means we are going to find the total number of count of its parent, that is of 1, and out of these 3 we are going to choose the maximum. And we are going to color it. So what we are going to do actually, we are going to find the left count of 3, right count of 3, that is going to be 6, sorry, not 6, that is going to be what, 1, and this is going to be 3, right? Why we are actually doing this? Let's see why we are actually finding the left count and right count. Let's say if I color this node, then maximum number of nodes I can color are 1. If I color this node 7, then the maximum number of nodes I can color are 1, 2 and 3. So from here I can only color 3 nodes. Now if I color this 1, then how many nodes I can color? 1, 2, 3, 4, 5, and this including 1 including, that is going to be 6. So I can color 6 nodes. So obviously I have to choose this maximum one, so that I can win the game, right? So here I am going to do what? I am going to find the, let's say x is given, I am going to find its left count, I am going to find its right count, and I am going to find the total number of count after excluding these two values, that is number of nodes in parent, that is obviously 3's parent is going to be 1. So number of node excluding parent, or exclude number of nodes in parent excluding this x, we have to find this. That is going to be what? That is going to be total number of nodes in the whole tree that are given to us, minus the left count plus the right count plus 1. Why this plus 1? This plus 1 is of this node, that is the first initial node that is going to be colored by the opponent. All right, so this is one thing. And after getting this, we have to actually check that if the left count is greater, that is if the left child of the x, that is the first node colored by opponent, are greater, or right child are the greater, or the parent is greater, and out of these 3 we are going to color. Why we are checking for left child and right child? Because there might be possibility that there might be this node, some node, here also 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 some node, and here also node. And let's say there is this another node. So how many nodes are there? 1, 2, 3, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, right? So there are total odd number of nodes. And now if I make if I make a color to, let's say if I color this 7, then I am going to get the maximum number of nodes from where? I am going to get the maximum number of nodes from this point, right? So I have to check for that. I have to check the right count and the left count, or from here, because we are checking the right count of this 3. So with this we will be able to find the maximum number of nodes that we can color. Okay, and after this what we have to check, we have to just check that if the number of colors, let's say I colored, let's say there is no tree like this, it is just this much, and from this point it is getting 6, we are getting 6 as answer, and from here 3 and 1. So let's say if I color the 6 number of nodes, that is my color, I'll say my is equals to 6, then can I win? Yes, I can win. How can I win? I can just see that my color is greater than, I have to check that if my color is greater than the opponent's color. So what is my color? My color is 6, and opponent's color is going to be what? 1 plus 3, 4, and plus this one node that opponent initially has colored, that is going to be what? 5. So yeah, 5 is greater than, so if 5 is smaller than 6, so we won this game. We can also check that, obviously, as we have seen that there are only odd number of nodes, then it is the highest possibility that, or it is going to be possibility that the winner will be having one node more colored than the opponent or the loser's color. So we can check that if my color is greater than n by 2 or not. We can see that here n is 11, so 11 by 2 is going to be 5. In integer value it's going to be 5, so 6 is greater than 5. So with this we are getting the correct answer, that we have won the, and we have to just return true or false. So I hope the explanation was clear to you all. Now let's code this question, and let's with that you will get a more insight to this question. So let's start programming. Yes, now here we can see that there are two functions given to us. One is to count the number of nodes. We have to complete this function, and using this function we can count the total number of nodes from any given node. Okay, from any given node. And left count is also given as static variable, right count is also given to us as a static variable. So now what we have to do, first let's initialize this left count and right count. Okay, now next thing what we have to do, we have to count the total number of nodes around this given x. So we are going to call this function count node, and we are going to pass it as root x as a value. Now next thing what we are going to do, from here we are going to get some value. So let's look after that what we are going to do. First let's complete this thing, this count function. The base case is going to be simple, that is if my root is equal to null, then what we are going to do, we are going to return 0. That means the total number of nodes to that null node is going to be 0, that is leaf node. Now we are going to make a call to left child, or to left part, that is going to give us the total number of nodes, or the count of the total number of nodes in the left subtree. And similarly we are going to make a call for right subtree. So we are going to pass what, node node with root dot left, and we are going to pass x as it is. Similarly we are going to call this right function, okay. Now what we are going to do, we are actually going to update this left count and right count, that is left count and right count. With this we are getting the left count, with this we are getting the right count. So to update this, what we are going to do, we are going to put a condition, that is if root dot val, that is the value of that current node, is equal to x, which means if we are at that position where the opponent has colored, then what we have to do, we have to update this left count with left and right count with right. And while returning, what we have to return, we have to return left plus right plus 1. This 1 is of the colored node itself, right? Now this function is going to return as the count of the left child and count of the right child. Okay. Now what we have to do? We have to actually, now we got the left count and the right count. Now we have to count the total number of nodes excluding the parent. Sorry, total number of nodes in parent excluding x. So to do that, what we are going to do? We are going to create a variable total number. Let's name it as total number of parent. Total number of nodes in parent excluding x. That is going to be what? N minus left count plus right count plus 1. This 1 is of that x, right? Now we got the total number of nodes in parent after excluding x. Now our answer is going to be stored at, let's say, max count. Our answer is going to be as maximum of what? Maximum of let's say max count, that is itself, maximum of max of left count comma right count. Now what we have to do, actually we have to, with this line, what we are actually doing, we have this left count, right count, and this count. Now we have to update our maximum count with the maximum value of these three. We cannot include this one, this colored node, therefore we will not be adding anything here. Now we have to check if my max count is greater than n by 2, then I have to return 2. This means I am the winner of the game, and if not, I have to return false. So with this, our program is complete. Currently, at this particular moment, I cannot run and compile this program because there are no test cases available on our website, but soon they will be updated. But this function, or these two functions, or this whole program is going to run correctly and is going to give us the right output. So you can also try this by just doing the dry run. Soon the test cases will be uploaded, then you will be able to see the correct answers and everything going live. So thank you for this video. I hope the explanation was clear to you all, how we actually find the left count and right count, and how we actually found the final answer. So thank you for this video. Let's meet in the next video.